Hello and welcome everyone to our channel Minute Tips. Today we will discuss one of the important topic, that is a volatile keyword in Java. We will learn what is volatile keyword, how it works and what is the use of this keyword. Before moving forward, I would request you to please like and subscribe our channel. Guys, I want you to first understand the internal working, how internally CPU, memory, cache, thread works. So I have taken a small example here. Here I have my main memory and then I have two cores here. Okay, so I have, let's say, dual core in my CPUs, core 1, core 2. In my core 1 I have a thread 1, okay, and in my core 2 I have a thread 2. Now both my core 1 and core 2 have its internal cache memory. Now my thread always interact with this cache 1 and this cache 1 interacts with the main memory. Similarly in my core 2, thread 2 interacts with the cache and cache 2 interacts with the main memory. So here I have taken one example of a visibility problem. Okay, so first we will learn what is visibility problem, how to solve it. Okay, so here I have one class volatile keyword learning. In this class I have one variable, that is int counter equals to 0, and I have one method increment. In my increment method there will be some logic. Okay, so this is the scenario that I have taken. My scenario 1 is thread 1 reads the counter value and performs counter is equals to counter plus 10, whereas my thread 2 just reads the counter value from main memory time to time. So here in my main memory first I have counter equals to 0, as I wanted to perform operation in thread 1, so this counter equals to 0 is loaded into cache 1. Now I am doing the operation and my counter value becomes 10. Meanwhile thread 2 tries to read the counter value and again it reads the counter value from main memory, but what happened is it is reading the old value of a counter, that is counter equals to 0. Even though the counter value is updated to 10 with thread 1, it is not yet reflected in my main memory. Okay, and that's the reason we call it as a visibility problem. Okay, so this value 10 is not visible to my cache 2 because this value 10 is not reflected in the main memory. I hope you understand a visibility problem. Now how to solve this visibility problem? So here this is the solution. What I have done is that the scenario is same and my code is same. What I did, I used a volatile keyword for my variable int counter. Just make a note guys, this volatile keyword cannot be used with classes or methods. It can only be used with variables, and that's the reason I have given it volatile here. Now the scenario is same. My counter equals to 0 in my main memory. Here my cache 1 is reading that value, so counter equals to 0. Then it performed operation, but before that my core 2 read the value from main memory, so here it became 0. So as we know that in multi-threading we cannot predict which thread is executing at what time. Okay, now my both the threads, both the values are updated in the cache 1 and cache 2 respectively. Now my thread 1, what it did, it incremented the value, it performed the operation, and once the operation is performed successfully, as soon as my thread is executed the counter equals to counter plus 10 and it is terminating, immediately the updated value is pushed into main memory. So now my main memory became 10, the counter value becomes 10, and as soon as the value is reflected in the main memory, it pushes its updated value to the other parts of the application who is reading this value, just like a refresh is done here. And in my cache 2, counter equals to 10. So now I got the latest value, okay, which cache 1, thread 1 updated. So this way we solve the visibility problem. But now volatile keyword is not only solution, because it can give some problem. Which kind of problem? A synchronization problem. So here what I did, I took one more scenario. That is, my thread 1 is again reading counter value and performing operation counter plus 10. My thread 2 now this time reads the value and also performs one operation, that is counter equals to counter plus 10. So similarly, both my thread will read the value from main memory, and now here my thread 1 updated its value to 10. Meanwhile, at some other place thread 2 also updated the counter value to 50. And when both the thread tries to push their value here in main memory, see which value should be updated, 10 or 50. So this is what a synchronization problem arises over here. So what is the solution for this? So with volatile, we need to use something for synchronization. And now moving my fourth scenario here, as we already used a volatile keyword for this variable, now my increment method, I made it synchronized. What synchronized means is at a time only one thread is able to access and execute this method. Once its execution is done, my thread 2 can interact with this method. So scenario is same. Thread 1 wants to increment the value by 10. Thread 2 wants to increment the value by 50. Similarly, as you can see, counter value is read by thread 1 and it updated its value to 10. Now it is synchronized. My value 10 is pushed to main memory. As soon as it is pushed, my thread 2 reads the value counter equals to 10 and then performs its operation. So counter became now 60, 10 plus 50 is 60, and this updated value 60 is pushed into main memory. Okay, so this way we solved the problem, the synchronization, that problem that we saw previously. So first problem is visibility problem that we solve with volatile keyword, but that was not enough. We saw one more problem, that is a synchronization problem. So we solve synchronization problem with synchronized keyword by making the method synchronized. Okay, so in this way we solve all these problems. Alternative to synchronized block, we have few more classes in Java under concurrent package. Okay, so we have atomic long or atomic reference, or there are few more other classes. We can use those classes. Few of the methods of atomic long class is as follow: get and add, get and decrement, get and increment, get and decrement again. Sorry, I think by mistakenly I copied it twice. So decrement and get. So these are the few methods which are all synchronized, and rather than keeping in mind to make a variable volatile, making a method synchronized, these methods we can directly use in our code. So I hope you understand a volatile keyword and the problem that we solve with the help of volatile keyword. What we solve, visibility problem, is what we solve with the volatile keyword, but it gave rise to synchronization problem. So with the help of synchronization keyword, we made our method synchronized and we solve that problem. Alternatively, we also saw there are few classes in Java, readily available classes, atomic, long, and which was the one other, reference. Okay, which we can use and solve our need. Okay, thank you guys.